All right. This is part two of the line-by-line code for a system check program for the LRC Python class. And so this video should be a little bit shorter. Basically, what we did in the previous video is we set up our trial class, we set up our program, and we laid the foundation for nearly every program that you would ever need to code in Python for the monkeys at the LRC. And so now we need to move into the more nitty gritty and the specifics for this task, which is a system check type of task where they hit a start button. Once they hit a start button, they hit a green square. Once they hit a green square, they get a pellet, and the next trial happens. So what we're going to be around line 191, which is just below the place where we set up the trial class and gave it all of these characteristics. So the first function we need is a new function. And so this new function is going to start a new trial. And so there's a couple things that we need to do when this function is run. There's things that need to happen. So one of them, we need to make sure that we increase our trial number by 1. And so the way we do that is we go self.trial number. What you could do is you could do self.trial number equals self.trial number plus 1. But that's typically not how we do things, just because it's much quicker and easier to do the following. So instead of writing all that, all we have to do is plus equals 1. And so all that does is it says self.trial number equals the previous number plus 1. So it basically increments a trial number by 1. And the same thing needs to go with the next line of code. So self.trial within block. This is also increasing, right? Plus equals 1. Okay. And then lastly, because it's a new trial, we want that chime sound to play. So in case there's a monkey that fell asleep during a long ITI or something, it'll wake them up and realize they need to start the task. So we'll go delete this line of code here, and we'll go sound chime dot play. And so this dot play function is a part of Pygame, and we've already defined sound underscore chime as being equal to chime dot wav, which is located in the file. So that's all that line of code will do. Next, we have a bunch of print statements here. You don't need these. I only have them in there because they're really nice to keep track of when you're coding the program. You know, it's nice to keep track of, is everything working? Are the trials advancing in trial number? What kind of trial type am I on? Why is it running like this? So print statements are super helpful for when you're coding the program, but they're actually not useful at all for the actual program themselves because the monkey will never see it. All this is doing is printing to the console, not to the actual program. And so I usually go through before I put it on the monkey computers and I remove all print statements. And the reason I do that is some print statements can actually slow the computer down. And I know you guys know that the LRC programs or the LRC computers can sometimes be dodgy or a little bit slow. So I usually just remove my print statements before I actually run them on the program. Next, what we need to do is when we start a new trial, there's one thing that needs to happen. We need to check to make sure that the previous trial was not the last trial within the block. And so say you have 20 trials in block. After trial 20, you don't want the program to just advance to trial number 21. You want it to know that it's the end of the block and do anything that needs to be done, like randomize your trial types or randomize your stimuli or what have you. You need to reset everything after each block. That way your program can operate in chunks rather than like having everything being lists of 100 things or 1,000 things, right? You can operate in smaller chunks that equal a larger sum. It also helps the program run faster too. So instead of randomizing a list of trial types that's 8,000 long, which would take the program like minutes to do, it can easily do a list of 20 trial types in less than half a second, and you can just do that each time a block ends. So it makes the program a lot more efficient. So what we need to do here then is we need to make an if loop, right? So let's do if self.trial within block equals equals. We could just do 20, right? Because that's how it is. But that doesn't really help us in case we need to change this later on. So we already have a variable that we've set up here as to being block length, which is the number of trials per block. So what we can do is down here, we can say if the trial within the block ever equals self dot block length, which does so happen to equal 20, but in other cases it may not, then we do a colon because we need to do something. We need to reset, so self.trial within block now equals back to 0, so we've reset it to 0. And then we need to, we'll say, maybe we want to print the word block complete so we can test to see if that's working, right? So maybe we do that. And then we need to run the function new block. And this new block function is where we're going to re-randomize and redo all these sorts of things. So self.new block, just like that. Awesome. Also within trial.new, so basically this is just a little chunk that we'll run new block, and we'll get to new block in a second, which is down here. It's super simple function, but just something we got to do. But so we're still in this new function, right? So we've incremented the trial number. If it's the last block trial within the block, we reset it and we run a new function. But we also need to reset all of our phases, right? So we're going back to the beginning of a trial. So we need to set all of our phases to false and reset our start phase back to true. And we need to make all of our events false again as well, because they may have become true within the previous trial. And then next we need to, see. Next we need to run another function. So, which once again, we have not coded yet, but we're going to get to it. So we're going to need to create the stimuli. And then we're going to need to move the cursor to the start location. And that'll be the end of that new phase, right? So let's do the create stimuli first. So self dot, we'll run a function. So self dot create stimuli. We'll get to that in 1 second. And then we also need to move the cursor. And so the way we do that is we call the object cursor. We call the function move to position. And then you can have it start wherever you want, but typically I like to start at the bottom of the screen at 400, 500. And so 400 is the center on the XY condition, and then 500 is 500 pixels down, which is 100 pixels from the bottom of the screen. Awesome. So there's new. Obviously, if you run this now, we have not coded this function or the new block function. And so we need to do that next. But that's what we need to do, right? So every time there's a trial reset, we need to reset the trial number. We need to reset the trial within the block or increment those by 1. We need to check if it's the last trial with the block. We need to reset all of our phases. We need to reset all of our events. We need to create the stimuli for the next trial. And then we need to put the cursor where it's supposed to be for the next trial. So real quick, all we're going to do here for a new block is we're simply going to increment self.block plus equals 1. Okay, super simple, not a very complicated function. I think in the other thing, I also sent all the events to false in case you had events that were block-wide events, like, I don't know what you might do, but yeah. And then lastly, we need to test within this function, we need to test if the block is the last block in the session, then we need to end the session. So we do this by this chunk of code right here. So you go, if self.block is greater than the number of blocks, self.blocks per session, so the number of blocks, so say you have 5 blocks in a session, then we're going to print the session's complete and we're going to quit the program now. So yeah, so that is the new block function, super easy. What you could do, you could take this entire function and simply plug it up here into where it says self.newBlock. But I like to make its own function because sometimes certain programs need certain things to happen in a block. So especially like I was telling you with the training, right? Sometimes at the end of a block, you want to calculate what their percentage was and then check their percentage, and all that's just better done in its own function. So that's why I have its own function there. And then the next function is a really important one. And this is where we're going to actually create the stimuli that are used in that trial. And that will involve creating stimuli that are also used in other trials, but specifically honing into the ones that we're going to use on this trial with this trial type. And so that's what we're going to do in this next function. All right, so the first thing we need to do is we need to create a list called icons, which we've already started here. And it needs to contain all the icons that we're going to have. And so the first icon is we're going to create a new object of the icon class. So we do that by calling icon. And then what are the three things we need to pass an icon? First, we need to pass the PNG or the image file that the icon is going to be. Then we also need to pass its location or its position. So where it's going to appear on the screen, which we can change, but for now we just need to give it something. And then also its size. And so that's also something that we can change as well. But I like to just go ahead and set up the size. If you don't have icons that are changing sizes, it's just easier to do it right here, right now. So the first thing we need to pass it, let's give it a PNG. So let's go start.png, right? And so what that's going to do is it's going to, when it creates this icon, it's going to go and it's going to open this PNG file in the program file. And you'll see it's going to be a start button here, right? So that's how it knows what to make it, right? So then comma, and then we need to give it a position, in which case I like my start buttons to be at 150, 200. But once again, we can change that real easily. So that's about, anyways, it's on the screen at 150, 200. And then I'm going to put the size set to 140 pixels by 140 pixels. Once again, pretty standard square pixel size, medium icon. And we can always change these, but we need to assign them now as is. So that's our first icon. But we're trying to make a list of icons. So we also need to have another one. So maybe our next icon is, oh, I forgot to end the parentheses there. This was giving me a weird. So maybe we want to, now we need to create, so we have the start button. We've already made the cursor. The next thing we need to do is create the icon that the monkeys are going to click to get a pellet. And so once again, we create an object called icon, and we need a PNG. So in this case, it's correct.png. We need to give it a position, which in this case, we're going to give it 0, 0 for now, because we're going to change that later. And we're going to give it a size of 100, 100, just like that. And so what this is going to do is it's going to go into the program file. It's going to open the PNG correct.png. Correct.png looks just like this, right? And then it's going to put it at position 0, 0 and make it size 100, 100. And then lastly, we're not going to do that for this program, but I'm going to go ahead and just add it in here anyways, because we'll use it later. We're going to do another one called incorrect.png. And this is going to be, once again, at 0, 0 and going to be the same size as the other one. So there we go. We've made a list of icons called icons that consist of 3 objects, 3 icon objects of the icon class. I know that's super confusing, but basically just remember, think of objects as their own instance of a class, right? A chihuahua is an object that is a dog of the dog class. Just like all of these icons, 1, 2, and 3, are all icon objects of the icon class. And so we've created those. And then now what we need to do now, we've created the icons. We need to plug them into the characteristic of the trial class called self.stimuli. And so self.stimuli we created up here, right? We created it already, a blank list called self.stimuli, ensuring that every trial had a list called self.stimuli that it's going to pull from within the trial. And so in this example, we're going to take those objects that we just made, and we're going to put them into the self.stimuli list. And so what this looks like is just like this. You got icons at position 0, icons at position 1 and icons at the position of 2, just like that, right? And so now self.stimuli, if I refer to self.stimuli at the 0 position, that's the start button. If I refer to self.stimuli at the 1 position, that's the correct button. If I refer to self.stimuli at the 2nd position, so 0, 1, 2, that is the incorrect button, right? Or the red square, which I didn't show you, but it's a red square. Now, you might be asking, why the heck did you just make 2 lists of the exact same thing? And you're right. In this case, I made 2 lists of the exact same thing. Icons and self.stimuli are identical. There's no difference between them. However, I like to do this because usually I use icons as a list of all my stimuli that I'm going to use for the entire task. So, and then self.stimuli is the list of icons I'm going to use on that specific trial. And so, for example, I may want to do something like this. I'll undo this because this won't allow the program to run because there's no such thing. But maybe I want to have 2 different trial types. One in which you have to click the green square and one in which you have to click the red square. The way I can do that is I can go if self.trial type equals self dot whatchamacallit, gosh, I'm blanking on this one. Give me 1 second. Yeah. So if self.trial type at the self.trial within block position, so that's basically saying if self.trial type of the trial type we're on equals 1, then we want the green button to be the correct answer. Else, if self.trial type at self.trial within block equals 2, which we don't have, but if we did, then maybe we want to just copy this down. Maybe we want the red box to be the correct answer and the green box to be the incorrect answer. Right, so that's a way you can sort of like manipulate the thing without having to go through and do all of this long form code and all of these if loops and all that kind of stuff. It's sort of a way to streamline the process. So I'm going to get rid of this now, but that's basically why I do it in that way. Gosh, let me get that back. Get rid of that if, and we're just going to leave it at that. Awesome. So now we do have a runnable program. We could run this and it's going to run trial.new, which is then going to increment the trial number by 1, increment the trial within block by 1, play the chime sound, print a bunch of this stuff out, check to see if it's the last trial within the block. If it is, now it has a function to run, which is all it is doing is increasing your block by 1 and then seeing if it's the last block in the session. Okay. And then it's also going down here, it's creating all your phases to the default starting position, creating all your events to be false, and then running create.stimuli. So it's creating the stimuli, which we just coded in that function there. I'm just creating the stimuli, and then it's moving the cursor to the start position. So we're good. So we have a trial. I have a feeling that if I run this, it's probably not going to work. We're probably missing some things still, but let me try real quick. Yeah, here we go. Look at that. It's running. There's no errors, technically speaking, right? So we've created a trial. We're on trial 1, but if you click your arrow keys, you'll notice it doesn't do anything because we haven't told it to do anything. We haven't told it can do anything. All we've done is set up a new trial and created our stimuli. Our stimuli are already on the screen because we haven't even drawn them yet, which is a whole other function entirely. So we'll go ahead and quit out by hitting Q and close that out there. All right. So now what do we need? What do we have left to do? We need to draw the stimuli on the screen. So we're going to have 2 different functions for that. We're going to have a draw the start button function, and then we're gonna have a draw stimuli function, which is just basically the same function. They're gonna look identical. They're gonna look very similar. But one of them is going to draw the self.stimuli at the 0 position, and one of them is going to draw self.stimuli at the 1 position. And then we also need a start function, which is going to allow the cursor to move and hit the start button. And it's going to draw the start button on there. And then we actually need a run trial function, which is going to allow the programs to run. So let's go ahead and just get right into it. So the first thing we need to do is we need to draw the start button. And the way we do that is we go here to this line of code here. Let's get rid of that. We're going to go self.stimuli at the 0 position. So remember, that equals icon at the 0 position, which equals the start.png. So we're going to take that self.stimuli at the 0 position, and we're going to run the function mv2pos, so move to position. And we're going to want to draw it at the very dead center of the screen. Maybe not quite the dead center. It's at the a little bit below center, but it's at the center of the screen there. So we're going to move the stimuli to that position. But once again, it's not going to be on the screen. So it's just going to be there, but you can't see it. So the next thing we need to do is we need to take self.stimuli. Goodness gracious. Stimuli at the 0 position, which once again is our start button. And we're going to actually draw it on the screen using the function .draw. And what do we need to pass .draw? Where we want to draw it. So we're going to draw it on the screen. So now when you run the function, right, it's not going to still do anything because this is just a function and we haven't called it anywhere yet. But we're going to do the exact same thing for stimuli, with one exception is we are going to move it to one of those positions which we established in the trial class. So remember, we established what self.icon position is right here. So we've done that. So we've added that, and instead of drawing it at 400, 400, where the start button is, we're going to draw it at one of those positions that we've decided and we draw on the screen. So once again, exact same function. But once again, if I run the program, this isn't going to do anything because we still haven't called these functions anywhere within the program. We've just now created functions. We're going to go ahead and skip this response time thing. If you have questions about it, it's just how you keep track of their reaction time. It's super helpful function. I just wanted to include it in there for you guys so you can see how it works. We need to actually run the functions. And the way we do that is running another function that will call those functions, right? So we're going to jump down to the start function. And this is the function that starts the trial. So every time we want a trial to run and that start button to be there, we want this function. So what do we do? I'm going to ask you guys, if this is our first function, we need a couple things to happen, right? We need the start button to be drawn on the screen, which we just coded a function for, so we're going to call that. We need our cursor to be able to move. We need our cursor on the screen in case it's not already on there. We need to just redraw it on the screen so you can see it. The monkey can see it. And then we need to check if that cursor collides with the start button, we need to advance to a different phase, right? So let's start with the easy one, right? Let's just use the function that we just coded, self.draw start. Now, whenever we run trial.start, we are going to draw the start button on the screen. So if you see here, if you run it now, look, the start button has been drawn on the screen because we called a function within the start function to draw it. But once again, I'm clicking the buttons and nothing's happening because the cursor can't be moved yet. So then quit out of that. So next we need to draw the cursor on the screen in case it's not already there. It was already there, but I just like to do that just in case. It's not going to like draw two cursors because there's only one cursor object. So it'll just redraw it on the screen. And then we need to allow the cursor to move. And so the way we do that is we go move cursor, which is a function from Matt's toolbox. We're going to give it the object that can move. In this case, it's called cursor. But you could do any object. You could move the start button around the screen if you wanted to. And we want to move it only in the up direction. And so that's the way you do that through that code. So now you can't move side to side or down, but you can move up to the start button. So now when we run it, we run the program, you'll see here, we have our task window. We got the start button drawn, the cursor's there. And now look, we can move the cursor. But, it doesn't do anything. I mean, it went right through that start button as if it wasn't there, right? That's because we still haven't added in the part where we need to tell the program, hey, if the cursor hits the start button, you need to do something. So let's do that real quick within this same chunk of code. The best way to do this is just simply through an if loop or an if statement, right? So if cursor, so we're calling the cursor object, collides with, which is once again a function within Math's toolbox. So if cursor.collides with self.stimuli at the 0 position, which is also known as the start button, then we need to fill the screen with the color white, right? Super simple. So before we add anything else, let's just make sure that that works. All right, so now when I touch the start button, the screen should go white. Oh, it did briefly, but then I'm still allowed to move my cursor. So then once my cursor is no longer colliding with my start button, it comes back again, right? And the screen is no longer white. So we still need to do a couple things, but it did work, right? So you saw, let me run it one more time for you. Watch very carefully. When the cursor collides with the start button, it's white, but if I keep holding that up arrow, it comes back because it's no longer colliding with it. So we got a couple more things we need to add to this little if loop. We need to advance the phase, right? So we don't want the screen to just go white. We need to advance from start phase to phase 1. So the way we do that is self.start phase equals false, right? So we're going to set that false. And then we're going to set self.phase1 equal to true. Now, that's sort of complicated, right? So basically what you're doing is you're advancing from start phase to phase 1. But you have to remember, this is all through the main game loop. So if you go back down here, what did we say? If start phase is true, we're running trial.start, which is what we've just been running. But the moment start phase becomes false, we are then telling the program to run a new trial, or having the trial run a new function called run trial. And so this is how we advance phases, and that's how you advance any phase. Once basically you do an if statement. If something is clicked, then you cause all the other previous phases to become false, and the phase you want to go to needs to become true, right? So in this case, we're going to do start phase equals false and phase 1 equals true because we need to advance from start phase to phase 1. We have all this to do, right? And then there's one other thing that I'm going to add real quick. This is just in case you guys want to learn about how to use time. I do this thing called self.start time equals pygame dot time dot get ticks, just like that. And basically all that's doing is creating your reaction time. So once you've hit the start button, start time is keeping track of how long they've taken to select something on the trial. So just wanted to throw that in there, but I'm not going to go too much into it. All right, we only really have one function left to code. And that function is the actual trial, right? So now they've hit the start button. So let's go ahead and see that in action real quick. Once they hit the start button, you'll notice everything freezes. I can't do anything. I'm hitting all the buttons. Nothing happens. The cursor's still there, but the start button's gone. That's because we've advanced to phase 1, which is going to run the function run trial, but we haven't told run trial to do anything yet. So that's our last step. So we're going to go in here, and there's a couple things we need to do. One, we need to redraw the cursor on the screen, just in case, once again, in case it got covered up or erased or something like that. We need to allow the cursor to move, once again, because that was only according to the previous function that we were only allowing it to move. Now it will no longer move because we're into a new phase. And we want it to move in any direction. We don't want it to just move up, so we'll do that. We also need to remove that start button stimuli just in case there's any sort of anything happening in the background. We just need to remove that, make it disappear. We need to draw the stimuli. So in this case, we need to draw the green box. And then we need to check, just like we checked for the start button, we need to check what happens if the green box is touched. So let's go ahead and code that in here. So first, let's go ahead. We've just wiped the screen, so we need to redraw it. So cursor.draw on the screen. And then move cursor once again, allowing the cursor to move in, and then this will allow it to move in any direction. And then we need to remove stimuli at the 0 position, dot move to position. We'll just give it something like -50, comma -50, so it's completely off the screen. And that needs to be double parenthesis box. And then I also like to just just set my start button just in case it's there. I'd like to set its size equal to 0 so it disappears entirely. So now the start button's gone, right? So if we run this program, oh, and then the last thing, and this is the important one, we need to draw the stimuli. So let's go self.draw stimuli, which once again, we just coded not too long ago, right up here, right? So it's the same thing as draw start. It's just drawing a different one at a different position. So, all right, now if we run the program, we should have a cursor that moves around the screen, as we do, right? But if I touch that green box, nothing is going to happen, right? So you can move it around, but it doesn't do anything, right? So we still have to add in, just like we had to add in with the start button, we need to add in that if statement. All right, so let's add that in. Here we go. If cursor dot collides with self dot stimuli at the first position, 0, 1, 2. So if it collides with that, then we're going to play the true sound. We're going to dispense a pellet. We're going to fill the screen with the color white. We're going to refresh the screen simply because we need to just clear everything, get everything back to its default position. We need to then have a time delay. So pygame.time delay of ITI, which is ITI is 1 second based on parameters.text, but 1 second needs to be multiplied by 1,000 because Pygame operates in 1,000ths of a second. So it reads that as 1/1000th of a second. So if you want 1 second, you need to take ITI and multiply by 1,000. And then we need to run self.new because the trial's over, right? So if the cursor collides with stimuli 1, then we're going to play the true sound. We're going to dispense a pellet. We're going to fill the screen with white, and we're going to refresh it and clear everything off of it. And then we're going to give the monkey a time delay, and then we're going to run a new trial, and it'll cycle back. So let's see what that looks like now. So now, once again, start phase is working. My stimuli appears. I hit it. I get a pellet. I get a good sound. I get an ITI of 1 really quick second, and it moves on to the next trial. I mean, that's the program right there. I'm not going to go too much into the rest of it because it's already a long video, but if you want to learn how to do like writing stuff into a data file, that's the next function on there, as well as some sort of randomization stuff. That should all be in the lesson below this video. But yeah, I hope that was helpful, and hopefully by doing this, you guys now know you can code your own program. So you can build off of this code, and we'll continue building off of it in the next lessons.